Question number 36. Attempt either option A or B. A. The above circuit is a part of an electrical device. Use the information given in the question to calculate the following. First, potential difference across R2. Second, value of the resistance R2. Third, value of the resistance R1. 6 upon 0.5, that is 12 ohm, not volt. So here it is 6 volt, and how much voltage will be here? That is 2 to the 4 volt. So part third is value of R1. So we need this R1. So first, for that we have to find the voltage here. So part 3, V1 will be equal to, or you can say net V will be equals to V1 here plus this V2 plus this, suppose V4, that is, suppose it is V4. So here it is 12 is equal to V1. We have to find this V2 is either from this or this. This is 6 volt, and this V4 is already, we have calculated I into R, that is 2 into 2, that is 4. So this V1 is equal to, that 12 is equal to V1 plus 6 plus 4. So V1 will be equal to 12 minus 10, that is 2 volt. And since I1 is 2 ampere, so R1, or you can say V1 equal to I1 R1. That means R1 is equal to V1 by I1. So here V1 is equal to IR1, V is equal to IR hota hai, so V1 is equal to I1 R1. So that means R1 is equal to V1 upon I1. And V1 is, we have just calculated 2 volt, and R1 we have to find, that is I1 is 0.5. I1 is 2 ampere here. I1 is, V1 is equal to I1 R1, that is equal to R1 is equal to V1 by I1. So V1 is here 2 volt and I1 is 2, that is 1 ohm. So this R1 is 1 ohm. So the answer, first part is V2 is equal to 6 volt. Second part, R2 is equal to 12 ohm. Question number 36. Here is the above question. This diagram is there, and you have to, in this question you have to attempt either A or B. So this is the part A. So here is the circuit. Here is 12 volt. This is the R1 resistor. Here the current is 2 ampere. Here is R2, and here 4 ohm resistor through which 1.5 ampere current is passing through. Again, this will be 2 ampere and this is 2 ohm. So we have to find first potential difference across R2. So V2, let us say that V2 is same as potential difference across 4 ohm resistance. Let us say V4. So that is I into R. So that is I into R. I means, this is, suppose this is I3, this is I2, so this is, we can say this is V3 here. So this V3 will be I3 into R3, that is 1.5 into 4 ohm. So I3 is 1.5 and R3 is 4 ohm. So this is equal to 6 volt. So V2 is equal to V3, that is equal to 6 volt. So the voltage across R2 is 6 volt. Similarly, you can find out the current I2, that will be equal to 2 ampere minus 1.5, that is 0.5 ampere. We need that later on. Find the value of resistance R2. So second part is, you have to find the value of R2. So R2 will be equal to V2 by I2. So V2 is 6 and I2 is 0.5. 6 and 0.5, so that is equal to 12 volt. So 12 ohm, sorry, this is not volt, this is 12 ohm, this is resistance 12 ohm. So R2 equal to V2 by I2, that is 6 upon 0.5, that is 12 ohm, not volt. So here it is 6 volt, and how much voltage will be here? That is 2 to the 4 volt. So part third is value of R1. So we need this R1. So first for that we have to find the voltage here. So part 3 V1 will be equal to, or you can say net V will be equals to V1 here plus this V2 plus this suppose V4, that is suppose it is V4. So here it is 12 is equal to V1, we have to find this V2 is either from this or this is 6 volt, and this V4 is already, we have calculated I into R, that is 2 into 2, that is 4. So this V1 is equal to, that 12 is equal to V1 plus 6 plus 4. So V1 will be equal to 12 minus 10, that is 2 volt. And since I1 is 2 ampere, so R1, or you can say V1 equal to I1 R1. That means R1 is equal to V1 by I1. So here V1 is equal to IR1, V is equal to IR होता है तो V1 is equal to I1 R1. So that means R1 is equal to V1 upon I1, and V1 is, we have just calculated 2 volt, and R1 we have to find, that is I1 is 0.5. I1 is 2 ampere here. I1 is, V1 is equal to I1 R1, that is equal to R1 is equal to V1 by I1. So V1 is here 2 volt and I1 is 2, that is 1 ohm. So this R1 is 1 ohm. So the answer first part is V2 is equal to 6 volt. Second part, R2 is equal to 12 ohm. And finally third part, this R1 equals to 1 ohm. एक बार फिर once again you can just see it. This is the circuit. This is say R1. So here it is some voltage is there. Current 2 ampere is passing through. This is 4 ohm resistor and current is 1.5 ampere. This is R2. Let us say here the current is I3. Here the current I2. So, and this is the resistance 2 ohm and the current is passing 2 ampere. So let us say this potential across this is V4. We will require it later on. So first part is you have to find the potential difference across the R2. So this will be same as this because these two are in parallel. So in parallel voltage remains same. So this V will be same as V3 is equal to V4. V2 is equal to V3, that is I3 into R3, that is 1.5 into 4 ohm, that is 6 volt. So this V2 is 6 volt. Now we need this R2. For this R2 we need I2. So I2 in this case, this total voltage, total current here will be equal to the current divided in this way and this. So this 2 equals to 1.5 plus I2. So that means I2 equals to 2 minus 1.5, that is equal to 0.5 ampere. So R2 will equal to V2 by I2. V2 is same, we have already calculated 6 volt, and I2 is just calculated here 0.5. So it is 12 ohm. Now third part we have to find this value of R1. So unless we find out the value of V1, we cannot find the value of R1. So for that, this total voltage will be the voltage here plus voltage here plus voltage here. That means this V is equal to V1, this plus this say V2 and this say V4. So this is V equals to V1 plus V2 plus V4. So 12 equals to V1 plus 6 plus 2 into 2, that is 4. So 12 is equal to V1 plus 6 plus 4. So V1 is equal to 12 minus 10. So that is 2 volt. So V1 is equal to I1 R1. So here the voltage will be I1 R1 and I1 is 2 ampere and V we have calculated 2. So R1 will be equal to V1 by I1, that is 2 by 2, that is equal to ohm. Question number 36 or B. As shown in the figure above, A and B are two lamps. Lamp A is rated at 12 volt 24 watt. Lamp B is rated at 6.0 volt. When lamp B is operated at its rated voltage, the current in it is 3 ampere. The values of R1 and R2 are chosen such that both lamps operate at their rated voltages. Based on the information given, answer the following. First, calculate the current in the lamp A. Second, state and give region for the reading of the voltmeter. Third, calculate the resistance of R2. Fourth, find the value of the resistance R1. Question number 36, B part. Although you have to attempt only one, but I am giving you both the solutions. So here this is a diagram. Here we have 15 volt. Here the lamp A and lamp B. With lamp B, a resistance R2 is connected there, and in the main circuit this resistance R1 is connected. So here it is the voltmeter V. So he says that this lamp A is rated at 12 volt 24 watt. 12 volt 24 watt, and B is rated as 6 volt. 6 volt. When lamp B operates at its rated voltage, the current in it is 3 ampere. So here the current is 3 ampere. The value of R1 and R2 are chosen so that both lamps operate at their rated voltage. Based on the information given, answer the following. Calculate the current in the lamp A. So you have to find the current. Suppose this is current I, so I say it is IA. So this is the rating, and when it is rated fully, that means P equals to VI. So in that case, PA will be equal to VA into IA for lamp A. So PA is 24, VA is 12, so IA will be 24 divided by 12, that is 2 ampere. So this is 2 ampere. So the total current I will be equals to 2 plus 3, that is 5 ampere. That later on we will be using it. And the second part is state and give reason for the reading of the voltmeter. So here this voltmeter's reading V will be equals to IR. And what will be the IR? That is equal to the resistance of this A. So IA into RA. Because we don't know this R2. So that way we cannot find it. So with that, because in parallel the voltage is same. Whatever voltage will be here, that will be the voltage across this plus this. So this is the total voltage. So that we can find out IA into RA. So that IA is P equals to, we know P equals to V square by R. So PA will be equals to VA square upon RA. So here RA will be equals to VA square upon PA, that is 12 into 12 divided by 24. So this 12 and this 2 is 6. So RA is equal to 6 ohm. Therefore, V is equal to IA into RA, that is IA is 2 into 6, that is 12 volt. So here it is 12 volt from here to here. Now the third part is calculate the resistance R2. So the third part, again this V will be equal to, I told you that this 12 volt will be equals to VB plus VR2. So this is 12, VB is 6 volt. So that is equal to VR2. So VR2 is equal to 6 volt. 12 minus 6 is 6. And that is equal to 3 into R2. So R2 will be equals to 6 upon 3. That is 2 volt. And now the fourth part is find the value of the resistance R1. So this, let us find out the V1. So V1 will be equals to 15 minus 12 volt. This 15 minus this plus this will be equal to 15. So this will, V1 will be equal to 15 minus this voltage. So that is 3 volt. So, and I1 is same as I, that is equal to 5 ampere. So R1 will be equal to V1 by I1, that is 3 upon 5. 3 volt upon 5, that is 0.6 ohm. So the answers are, first answer is IA equals to 2 ampere. Second answer is this voltage V is equal to 12 volt. This V is equal to 12 volt. And third is R2 equals to 2 ohm. And fourth is R1 equals to 0.6 ohm. Once again you can see this is the circuit. Here it is 15 volt. This is the lamp A, which is rated at 12 volt and 24 watt. And this is the bulb B connected with the resistance R2 in series. And the rating of this B is 6 volt. The value of the R2 and R1 are adjusted in such a way, and they are chosen in such a way that these two bulbs are working at its rated value. So we have to find first the current through the lamp A. So since lamp A is working at this rate, so P is equal to VI. So PA will be equal to VA into IA. So 24 is equal to 12 into IA. So IA will be 24 divided by 12, that is 2 ampere. So first part is okay. Now since this current is 2 ampere and this current is 3 ampere, so the total current I, which is equal to I1 here also, that will be 5 ampere. Now the volt, second part is a voltmeter reading, and why it will take this reading. The reading will be here in parallel, since lamp A and lamp B plus R2 in series are parallel to each other. So whatever voltage will be here, that will be the voltage same here, and the voltmeter will measure same value here. So this V will be equal to IA into RA, we can find out. For this we need this value of RA. So we know P equal to V square by R. So PA is equal to VA square by RA. So RA is equal to VA square by PA. So V square means 12 into 12 divided by 24. That comes to 6 ohm. And therefore V is equal to 2 into 6. That is 12 volt. So this V will be 12 volt. The voltmeter reading will be 12 volt. Now the third part is we have to find the value of R2. The value of R2 is again this total voltage here is 12. So that is the voltage across this plus voltage across this. So voltage across this bulb is 6 because it is working at its rated value. So this is 6 and this we have to find. So this V, the voltage across R2 is V R2, that is equal to 6 volt. That should be equal to I into R. So 3 into R2. So R2 will be equal to 6 by 3, that is equal to 2 ohm. And finally fourth part is find the value of the R1. This value of R1 will be equal to V1 by I1. Whatever here it is I1, that I1 is equal to I. So V1 is equal to 15. This voltage plus this voltage is equal to 15. So this V1 is equal to 15 minus this 12. So that is 3 volt. So I1 is equal to I, that is 5 ampere. So R1 is equal to V1 by I1. So that is 3 upon 5, that is 0.6 ohm. So this is all about this question. Question number 39. The above image is that of a reflecting telescope. Reflecting telescopes revolutionized our ways of looking into the sky. They employ mirrors to gather and focus light rather than relying solely on lenses as in their refracting counterparts. These telescopes utilize precisely shaped and polished mirrors to capture incoming light and reflect it to a focal point where it forms an image for observation. A. What kind of image of the star is seen by the observer at the eyepiece? B. What kind of mirror is used in this reflecting telescope? Attempt either subpart C or D. Then C is explain with region what kind of optical device, yani lens or mirror, that is used at the eyepiece. D. What is the role of the plane mirror in telescope? Now question number 39. This above image is that of a reflecting type telescope. Reflecting telescopes revolutionized our ways of looking in the sky. They employ mirrors to gather and focus light rather than relying solely on lenses as in their refracting counterparts. These telescopes utilize precisely shaped and polished mirrors to capture incoming light and reflect it to a focal point where it forms an image for observation. A. What kind of image of the star is seen by the observer at the eyepiece? This is the eyepiece and this is the objective mirror and this is the plane mirror. B. What kind of mirror is used in this reflecting telescope? This mirror is already visible here. It is what kind of that we have to tell. And we have to attempt part C and D, only one. And C says, explain the region what kind of optical device or type of lens or mirror that is used at the eyepiece. And D, what is the role of the plane mirror in this telescope? So the part 1A, what kind of mirror, what kind of image is formed in the eyepiece? Because they are actually meeting, so, and it is the convex lens which is converging it, so the image is real image. That's the answer. And the reason is because it is being the rays are actually meeting, that's why the image is real image. And answer B, what kind of mirror is being used here? So as it is seen, the outer surface is polished and the reflection taking place on the inner surface of the curved surface. So this is concave mirror. Concave mirror. And C part, you have to answer either C or D. So, but I am giving you both the answers. The C is explain the region that what kind of optical device, yani type of lens or mirror that is being at the eyepiece. So, ये eyepiece में आप ध्यान से देखें तो it is a lens. So, it is convex lens. convex lens is used because it is converging lens. It has to converge. And the D part, what is the role of the plane mirror? The role of the plane mirror is to invert the image. The plane mirror ka role is the invert the image. So the real image will be there, but it is inverted. So plane mirror is already inverting it laterally. So the role of this mirror is role of plane mirror is to invert the image. So it is inverting the image. And one more rule is there. This plane mirror is diverting these reflected rays to eyepiece also. This is the another. If you will not use this plane mirror, then these rays will be somewhere and they will be not be able to reach to the eyepiece. So these are the rules of the plane mirror. So here, first thing is the image formed at the eyepiece or eye lens is real because it is converged by the convex lens, and convex lens form the image, real image. Second is what kind of mirror is used, the B part. They observe it is clearly visible that the mirror is concave mirror. And third thing is this eye lens is what kind of device? It is a lens, and it is the convex lens because it is to converge the rays coming from the plane mirror. And D, the role of the plane mirror is it is going to invert the image. The second thing is second role is to send or to make these rays divert to the eyepiece. That means the rays are directed from the plane mirror to the eyepiece. In the absence of plane mirror, these rays will not be able to reach to the